Hello everyone, my name is James, and today I will be going over question 3B from the 2023 Set 1 of the AP Physics C Electricity and Magnetism Exam. So first we need to of course read question 3 itself. The circuit shown consists of a battery of EMF, resistors 1 and 2 each with resistance R, capacitors 1 and 2 with capacitances C and 2C respectively, and a switch. The switch is initially open and both capacitors are uncharged. At time t equals 0, the switch is closed to position A. So when t equals 0, the switch will be like that. So now that we've read question 3, let's read question 3b. On the axes shown, sketch graphs of the charge density on the positive plate of capacitor 1, okay? So we're talking about capacitor 1, and the total power dissipated by the resistors as a function of time from t equals 0 until steady state conditions are nearly reached. Okay, so to find the charge density of the capacitor, we need to think about what is happening as the charge is going through the circuit. So to visualize this, we are going to use the diagram from question 3 to figure out what is happening. So here we have this here. This is the diagram, and we know that the charge is going to be going around, and it'll be coming up onto this plate. It'll be coming onto the capacitor. Now, pretend we are dealing with water. Now, the capacitor would act like a water tank. So as water is being pumped into the tank and going through, the amount of the tank that is filled with water will increase. Now, we can think about it as if it were the water with the water tank. So we can see that the charge will go through this here, and over time it will build up on the plate of the capacitor, which will increase its charge density. So in this case, we know that the graph will need to be positive and concave down because the rate at which the volume, if we're using the water tanks analogy, is increasing is decreasing. So the rate of the rate is decreasing. So therefore, it's going to be concave down. And we also know that there will be a horizontal asymptote where the charge density will reach a maximum. So we're going to draw a increasing line that is concave down and has an asymptote. And to get full points on the exam, make sure you put a vertical asymptote that they can see. So that is that, and that isn't really a straight asymptote, but for all intents and purposes, let's say it is. Now, for power, to create the graph for the total power dissipated by the resistors, we are again going to look at the diagram from question 3. So if the capacitor is a water tank, then the resistors are areas in the pump which have a smaller area for the water to get through than the rest of the pipes. So again, we can think about this as if it were the water with the narrower pipes. So using the equation, power is equal to current squared times resistance, which is found through using Ohm's law. We are able to create a graph for the power. So we know that the current is going to be less over time due to the capacitor. So we know that the graph is going to be decreasing, and it will be going towards 0. So we know that it will start up here, and then it will decrease to 0. So some common mistakes that students might make would not be adding the vertical asymptotes to their graphs. Now, it is important to remember that the charge density will be approaching its maximum, and the power will be approaching 0. To recap how we were able to complete these graphs, we used the diagram to obtain a greater understanding of the problem, as well as using Ohm's law for the second graph. Be sure you always have a good understanding of the diagrams and what is asked before you try to jump into solving the question. In the description of this video, there will be links to all of the full FRQ tests that were released for Physics 1, Physics C Mechanics, and Physics C E&M from 2023. If you have any questions or need additional information, please feel free to leave comments and I will answer them. Thank you for watching.